Hello, my name is Akash, and I'll be presenting my project, which is based on a paper which was published in International Journal of Production Research. My project title is Store Item Demand Forecasting using Deep Learning. So let's get started. Demand forecasting. Why is it needed? So in manufacturing and in retail industry, demand forecasting helps a lot while planning marketing strategies and also to find out customer behavior according to the market or the current trend. Solving demand forecast problem helps in building marketing strategies and portrays a paradigm shift in consumer behavior and risk mitigation strategies like managing the inventory as well as resource and expense management, which is very essential for such big industries and manufacturing companies. There are several forecasting methods which are based on statistics. One of them is like Arimax. These traditional methods try to identify trend, seasonality, and noise from these time series data, these demand time series data for effective prediction of the forecast. In a related research published in Journal for Retailing and Consumer Services concludes that artificial neural network works efficiently over these traditional methods. Another related research from International Journal of Neural System suggests that among artificial neural networks, LSTM works more efficiently given the property of recurrent neural networks with the gated complex network. It helps a lot while finding the trend and seasonality and train our model over it. To further improve the forecasting results, the current method proposes to use two models, LSTM and random forest. LSTM, as usually it is used for forecasting, demand forecasting. So it is fed with time series data of the demand, and after finding out a best model using grid search method, uh, the training data is again used to the training data is being predicted to find out residuals. These residuals are then fed to random forest as a target variable, and random forest uses the explanatory data from the transactions, for example, average price unit for a product, uh, number of customers bought that product on that day. Such data is being used, such explanatory data is being used by random forest to predict these residuals. Finally, while predicting the future forecast, the the aggregation of both the results is our final result. As I mentioned, LSTM best LSTM model is being selected after going through a grid search cross validation. So I have implemented a function for this grid search where I'm trying to find out how many number of layers or which activation function and which optimizer is best suited for a particular product. So I'm predicting, I'm building models for all the products which are available. So these are the results from the best LSTM model for a product. These results are for 31 days, and as we can see here, the blue line is indicating the actual values, and the orange line are indicating the predicted LSTM values. So just from the LSTM, we are getting an MAE of 74.28. As we can see here, from the previous LSTM predictions, after adding the residuals that were predicted from the RF model, the MAE has been reduced with a very significant amount. So it went from 74 to 34. So which concludes that LSTM plus RF random forest works better for time series data. Concerning to the future work, we can find out more explanatory data that can help to predict these residuals which are coming from the random forest model, which will eventually improve the results for forecast.